Hey everyone, welcome back to our Pandas AI series. Today, we're going to talk about something really important, the limitations with our current setup. You might have noticed that when using the API for Pandas AI, you could run into some usage limits. These limits can become a problem, especially if you're trying to do a lot of data analysis without spending extra money. But here's the good news. If you have a decent GPU, we can get around these API limitations by using Ollama, a local large language model. Of course, if you're okay with the current setup and sticking to the API, that works too. But if you want to have the ability to use Pandas AI without usage limits, this video is for you. Alright, so let's get started by installing Ollama. I will be showing this installation on Windows, but the steps are virtually the same for Mac and Linux. To start, head over to their website. I'll drop the link below, and you can download Ollama and start serving it locally. I will speed up installation here, so feel free to pause the video until your installation is completed. Once you have Ollama installed, you can now interact directly with a large language model inside of the terminal. I will show an example here with the Llama 3.1 model by running the command Ollama run llama 3.1. It might take a couple of minutes to install the model, so I will speed up the video again here. Once the model is running, we can verify it works by simply chatting with it, just like you would with ChatGPT perhaps. If Llama gives back a natural response, we know that it's working. You can leave the conversation by typing /by. Ollama comes with several models that you can use. Let me quickly show you some of these models. You'll notice that they vary in parameter size, which is a measure of their complexity, and whether or not they're fine-tuned for specific tasks. For this series, I'm going to use the Mistral-nemo 12B model. It's a state-of-the-art 12B model built by Mistral AI in collaboration with NVIDIA. I personally think this model has a great balance between performance and capability, but the model that works best for you can vary depending on your specific hardware. So feel free to experiment with different models to find the one that works best for your system. Before we dive into the code, I want to point out that my environment might look a little different from yours. For the rest of the series, I'm actually going to be running Ollama on a Linux SSH server because my laptop's GPU isn't strong enough to handle it. However, the setup on my SSH server is identical to what we're doing here today, just on Ubuntu instead of Windows. If you're interested in learning how to set up Ollama on an SSH server, let me know in the comments, and I can make a future tutorial about it. Now let's run the Mistral-nemo model so we can use it in our code. We can do that by typing Ollama run Mistral-nemo. This may take some time if it is your first time running Mistral-nemo. Alright, with the model running, let's walk through the Python code you'll use to integrate it with Pandas AI. First, we need to import the necessary classes. So let's start by importing Smart Data Frame from PandasAI and Local LLM from pandasai.llm.local.llm. Next, we need to set up our local LLM using Ollama. We'll create an instance of local LLM and point it to the server running on localhost at port 11,434. We also need to specify the model we want to use, which in this case is Mistral-nemo. We can also set a temperature parameter, which controls the randomness of the output. For the sake of this tutorial, I will use 0 as my temperature parameter, since that keeps my model output consistent. Now that we have our local LLM set up, let's initialize the Smart Data Frame. We'll pass in our stock data CSV file, allstocks 5year.csv and configure it to use the Ollama LLM we just created. Once the data frame is set up, we can interact with it using natural language. Let's ask it a question. Specifically, we'll ask for the average open price for INTC in September of 2016. Finally, let's print the response so we can see the answer. Make sure your virtual environment is active in the terminal and then run python mistral.py. Let's give the model a second to generate its answer and see what it gives us. And there you have it. I hope you found this tutorial helpful. If you did, please hit that like button, drop a comment if you have any questions or suggestions, and subscribe so you don't miss the next part of our series. In the next video, we'll be learning how to scrape the latest stock data and have it interpreted by our local LLM. It's going to be really cool, so stay tuned. Thanks for watching, and I'll see you in the next one.